Okay, so for this problem that I gave you to get ready for this next test, this is material that we covered in Chapter 2, but it's presented just a little bit differently than the way the homework was given in Chapter 2. So I just wanted to walk through this problem with you. You'll remember, I hope, covering this material, but I just want to make sure you're aware of how it's going to be delivered when you do this on your test. So given a graph like this, and it won't be exactly like this, but it'll be similar, we're supposed to determine the domain and the range. All right, so I hope you can identify that if you look at this graph, it's going to continue to go left forever as it goes down. It's going to continue to go right forever as it goes up. And so the domain is just going to be all real numbers. And I'm going to use interval notation to represent basically all my answers here that need that type of answer. Not all answers will be in inequality or interval notation. So the domain, all real numbers, and in interval notation we would say it like this. And that's going to be true also for the range because it continues going up, positive y-axis, and down the negative y-axis. So both domain and range in this case will be all real numbers. So remember what it means for a function to be increasing. Increasing means as you go from left to right on the graph. Let me just give you an example of where this function is increasing. Just think of walking uphill, or I know this isn't really truly a line, but think of positive slope. So it's increasing on this interval, and it's also increasing on this interval. So the way I state this in interval notation, it's increasing from negative infinity and until it gets to this point. And when you're doing interval notation, you're only using the x coordinates to express the intervals. So I'm coming from negative infinity and I'm stopping at -2. Now it's not exactly increasing at -2, so that's why I'm not going to do a bracket here. Okay, so that's one interval where it's increasing, and I'm going to combine that with this other interval which starts at 2 and it goes to positive infinity. All right, so that would be my increasing intervals. So I'll just erase that. And now let's talk about where it's decreasing. All right, decreasing would be walking downhill. And the only interval where this function is decreasing is here. And again, when you're using interval notation, you're just using the x coordinates. So it's decreasing from -2 to +2. And that takes care of that. Okay, now let's talk about relative maximum, relative minimum. A relative maximum is a turning point that results from going up and then hitting a point, changing direction, and then going down. So I have a relative maximum right here. And the value, whenever you see something that wants a value, it's talking about the y coordinate. So I'm going to state it like this. I have a relative maximum value of 1 that occurs at, and the at is where the x coordinate is, at x equals -2. The value is the y, and where it actually occurs will be the x. And that's the only relative maximum I have. Remember, it's got to be a turning point. You might be thinking, well, this is the highest point, and that's not what we're talking about with relative max, relative min. We're talking about turning points, and maximums will be peaks, and minimums will be valleys. So this point right here represents a relative minimum, where I'm changing direction from down to up. All right, so the value of that is -1, and it occurs at x equals +2. Okay, and we're almost done. Remember, we talked in Chapter 2 what it means for a function to be positive or negative. The function is positive where it lies above the x-axis, and it's negative for all parts that lie below the x-axis. So on this graph, the parts that we'll start with the part that is above the x-axis, and you can tell that that is this little piece right here. And using interval notation, we would say that that is between the x of -3 and 0. And once again, we won't bracket those because right at on the x-axis, we're neither positive nor negative. So the positive begins as you go above -3, and then it ends as you approach 0. And then there's another area that is considered positive above the x-axis, and it's this part of the graph right here. So we're going to combine our previous interval with this one, and this one starts at 3, x is 3, and it goes to positive infinity. So those are the positive intervals, the intervals where the function is positive. And now let's take a look at where the function is negative. So the function is negative here. Remember, that means below the x-axis, and also here. All right, so for this interval, always when you're doing interval notation, remember the smaller of the two numbers goes on the left, and obviously negative infinity is going to need to go on the left, so we're coming up from negative infinity and we're stopping at -3. And then we're going to combine that with this interval here from 0 to 3. And that should take care of our intervals where the function is positive and where it's negative. All the other pieces of information look good. So just be prepared on your test for a problem that looks much like this. You're going to be asked to find the same types of things. Of course, the graph will look different. But just wanted to give you a heads up on how to answer this particular problem, which will actually be on Thursday's part when you do that part of the test. So if you have any questions about this, you're welcome to email me or stop by. Be glad to help you. And let me know if you need anything.